In this lesson, we're going to take a look at real-world linear inequalities. So how do I solve and graph real-world inequalities? You are going clothes shopping and can spend at most $150 on clothes. It costs $30 for a pair of pants and $25 for a shirt. Let X represent the number of pants and Y represent the number of shirts you can buy. So our X is going to equal to the pants, the number of pants, and the Y is going to represent the number of shirts. So let's write our inequality. So we have $30 for a pair of pants, so $30 for every pair of pants you buy, plus $25 for every shirt you buy. Now it says you can spend at most $150. So you cannot spend more than $150. You can spend all of the $150, which would be equal to, and you can spend less than that. You don't have to spend all of the money. So you would have less than or equal to then $150. All right, so now we need to graph this one. I think this one would be easiest to graph by using the intercepts. So, which means I'm going to plug in 0 for my y to get the x-intercept, and I'm going to plug in 0 for the x to get the y-intercept. So this is what that will look like. So looking at this one, I think this one would be easiest to graph by using the intercepts. So I'd be plugging in the x for 0 to get the y-intercept and 0 for y to get the x-intercept. So let's go ahead and plug that into our inequality. So when x is 0, I would have 30 times 0 plus 25y is less than or equal to 150. So I'd have 25y is less than or equal to then 150. So let's divide by then 25. And y is then less than 6. All right, so when x is 0, y is 6. All right, let's then do the same for the plugging in 0 for y. All right, so you have 30x plus 25 times 0 is less than or equal to 150. So 30x is less than or equal to 150, and you're going to divide by 30. So x is less than or equal to then 5. All right, so there we have it. So let's go ahead and graph these intercepts. So I have 0, 6, and I have 5, 0. And because we have at most, which is the less than or equal to, you're going to have a solid line, and then anything that is less than that as well. So let's go ahead and talk about some possible combinations. So any of these coordinates, let's just talk about a couple of them that are directly on that line. And then any of these that are inside here as well, any of the coordinates that are in the shaded area. So the first point I had graphed is 0, 6, which means that you would have, if you bought 0 pants, you would have purchased 6 shirts. Meaning you would have spent all of your money on the shirts. Notice that 6 times 25 is equal to 150. Let's take a look at the other point here that I have 1, 3. In that case, you would have 1 pair of pants, and you would have 3 shirts. Also, if you looked at this, notice you would have spent 1 times 30 would be $30, and 3 times 25 would have been $75. So you would have taken 30 plus 75, and notice that that is not, that you would not have spent all of the $150, but you would have spent some of the $150. So anything in that shaded area, you're not spending the whole thing. So if I had our 3 pants and 1 shirt, so you'd have 3 pants and one shirt could have been another combination. And again, a 3 pair of pants would have cost you $90, and that one shirt would have cost $25. So you would have only spent, in this case, $115. And then let's just do one more combination, which would have been the 5, 0, and in this case, let's erase this. In this case, you would have had 5 pants and 0 shirts. All right, let's look at one more example. It says a debate club at your school needs to have at least 20 members made up of sophomores and juniors. Let X represent the number of sophomores and let Y represent the number of juniors. So let's start by writing this inequality. So our X is the number of sophomores. And so really all I have here is I have sophomores. And I have my juniors, which is my Y. And then it has to be at least. So you can have 20 members, but at least you cannot have less than that, but you can have greater than or equal to then 20. So let's graph this one. So I would have then, when X is 0, let's plug this in, and I think this one as well is easiest to just do by plugging in the intercepts 0 and 0. So when X is 0, Y is 20. And when then Y is 0, X is going to be 20. So let's graph that. I have 0, 20, and I'd have 20, 0. All right, so it has to be at least. So in that case, it's going to be a solid line again. And so because it was at least, it's greater than or equal to, it has to be anything up in this. So it can be any member, any combination of members that are on the line, and any combination of members that are going to be in the shaded area. So it's saying, could the club be made up of 15 sophomores and 10 juniors? So let's plot that, 15 sophomores and 10 juniors. Because that falls within that shaded area, yes, this is going to be, you could have the combination of 15 sophomores and 10 juniors. Could the club be made up of 10 sophomores and 5 juniors? So notice how this one's going to fall where it's not shaded. And so you'd only have 15 members there. And so remember, you have to have at least 20 members. And so no, you could not have this combination. So in this lesson, we took a look at how to write and graph and determine whether or not different combinations are solutions to that inequality.